Thank you, Dr. Nicholas. It is a blessing to be here, and you can tell, and I still have my laryngitis. It's due to a cold, really. It's overworking my voice, and you're probably wondering, are you feeling any better? And the answer is no. I think I'm feeling worse. So it's not your weather. It just has to run its course. And I can tell you, as a medical doctor, it will run its course. It will get better. But right now, I'm in the stage where we would say I'm shedding virus. You know, I came to medical school as an engineer, and they use these weird terms. You're shedding virus. So I've been keeping my distance from a lot of people, like about 4 feet away, so I don't shed on you. And I've already, unfortunately, shed on my wife. And so she's getting a little voice. So if you come into my space, you do it at your own peril. So you might get shed on, and in a week you'll be sounding like me, and then you'll be saying that whatever made me sick. So, well, Dr. Franklin had a wonderful talk. He asked where I was. Did you remember that? He says, "Where's Randy?" And I was listening to him in the library, keeping my distance from everybody on the back couch. So don't go sitting on that couch. Anyway, I was there. He mentioned the Dead Sea Scrolls. And when I was a Moody student, I was just a brand new believer. I don't even know why they even let me into Moody. I was so new. And I was taking the book of Romans, and I was reading through Romans, as we had to read it through every week for the entire semester. This is when they used to crack the whip on you, and they made you read it in different versions. And a verse jumped out at me on a prophecy that was literally being fulfilled as I was sitting there reading the book of Romans. And it was one of these things where everybody said, how can you prove any prophecies that are actually fulfilled? Well, in the book of Romans chapter 15, Paul is saying how he has this ministry to the Gentiles. And then he said this in chapter 15, verse 12. And again, it says Isaiah, again, as Isaiah the prophet says, there shall be a root of Jesse, and he that shall rise to reign over the Gentiles, and in him shall the Gentiles trust. And as I was sitting there, I was thinking, I'm doing this right now. I'm doing this right now. And this is a prophecy from Isaiah chapter 11. And he says it in verses 1 and verse 11. So if you want to remember it easy, Isaiah 11, 1 and 11. That there will be this root in this stem of Jesse who will stand as an ensign to the nations. And to him shall the Gentiles trust. Now just think about that. That is in the Dead Sea Scrolls. Dr. Franklin, that is in the Dead Sea Scrolls. 200 years, as he was saying, BC. 150 to 200 years BC. Could you imagine making a prophecy right now, today, that I believe this was 700 years BC, personally, but you can prove it 200 years BC, that 200 years from now, somebody from Ukraine is going to rise up, and 1,000 years later, people from all over the world are going to be believing in him. That's a pretty incredible prophecy. And this one is, everybody sees it as literally being fulfilled, because literally hundreds of millions of Gentiles have come to the Lord Jesus Christ. It has nothing to do with human reproduction. But it was a follow-on to what Dr. Franklin was saying last night from Dr. Hocking. And it just struck me, this was one that just, if you want to have someone ask you, can you show me a prophecy that's literally fulfilled? Turn to Isaiah 11. This root of the stem of Jesse, at the very minimum, it is a Jewish person that a bunch of Gentiles are going to come to worship. And it has literally been fulfilled for your eyes. Well, I did this talk on Darwin or Design, 3 Things You Need to Know, on my very first visit here. So some of you with really long memories may remember some of these things, but it has been updated. In fact, I've even added 3 things you need to know that were on there, and we'll move along rather quickly. And the very first one is, this is a new thought, that worship should be the normal response to science. You know, we think the trumpet playing and the good singing and trombone, excuse me. Don't want to get on the bad side. Anyway, so all of those things, that should lead us to worship. But really, science is a gift of the Lord, and it should lead us to worship as well. And we've all said this verse that David says, I am fearfully and wonderfully made. Is that not true? Of course it is. Some of you look in the mirror and you're more fearfully made than others. We know that is true. But we never quote the whole verse. Well, we always say is, well, I'm fearfully and wonderfully made. But David says this, I will praise you. I will praise you because I'm fearfully and wonderfully made. And it's not a superficial praise because he says, and this my soul knows greatly. Greatly. And you know, another one, since I'm talking off the top of my head, Psalm 19 verse 1, it's, don't flicker, the heavens declare the glory of God. And we almost always use it as the heavens declare the existence of God. Well, of course they do declare the existence, but it's more than just his existence. It is his glory, his splendor, his power, his genius. And that's what we want to declare today when we look at human reproduction. The second thing we want to know is, and you can be assured of this, is that everybody sees the design in nature. As Dr. Franklin said, they're just denying it when they say they don't. But you can rest assured that they do see it, because God says they see it. He says he has shown it unto them from the creation of the world, being understood by the things that are made. So he says it's clearly seen. If he says it's clearly seen, then that means everybody clearly sees it, even if they're denying it. Deep down inside, they're clearly seeing it. And if you get into a long enough conversation with them, particularly in private, guess what? After 20, 30 minutes, they back up and they'll kind of confess, yeah, I kind of see this stuff. And it almost always comes out with them. So you can be assured when you're talking about something like human reproduction, or you're holding up your hand, that these people are seeing it because God is showing it to them, even if it's not verbally expressed. And so therefore everybody sees the design, even atheists. Jerry Coyne, an outspoken atheist, hates Christianity. I don't know if he hates Christians, but he hates Christianity. Page 1 of his definitive work, Why Evolution is True, says, if anything is true about nature, it is that plants and animals seem intricately and almost perfectly designed for living their lives. Nature resembles a well-oiled machine with every species an intricate cog or gear. What does all this seem to imply? A master mechanic, of course. A master mechanic. That's what it implies. He sees it. Richard Dawkins sees it. Everybody sees it. And then, of course, he's going to go on to willfully deny it. But he sees it, and it's there for everybody. And then number 3, biological systems. And at ICR, we're trying to make a push into the creation camp to turn to some systems thinking and systems biology. Everything is going to work as a system. Your body is a big system. You have multiple systems. Yesterday, when I talked about the so-called immune system, I changed it to another system, a what? An interface system. A system that has multiple parts working together for a purpose. And that's what all systems are. And in fact, that explains biological complexity, which is multiple parts working together for a purpose. And that's what we see in this system right here. And they are going to display all or nothing unity, in which all the necessary parts are at the right place, at the right time, in the right amounts, or nothing is going to work. And we're going to see this in the human reproductive system. And in fact, Charles Darwin, to his credit, he used this even as a test of his theory. He said, if it could be demonstrated that any complex organ existed which could not possibly have been formed, and here are the words I'd like you to memorize, by numerous, successive, slight modifications. What are they? Numerous, successive, slight modifications. My theory would absolutely break down. Well, let's see if at the end of this talk it's broken down. That's what we're after. We want to see if it's broken down and see if we can explain this stuff in human reproduction by numerous successive slight modifications. Now this is what makes these talks glorious, and that is, I can't just tell you it's very, very complex. I have to show you that it's very, very complex, which means I have to dive down a little bit into the technical details. You have to submerge yourself into some technical details so that you get the full experience of just how glorious this is. And believe me, I don't think evolutionists really want you to understand this because it would be so obvious. So if I'm not getting technical enough for you, and you're saying, wow, I'm really lacking on some technical level here, Dr. Guliuzza, just yell it out. Crank it up. Crank up. And I'll crank it up a little bit, okay? So we'll do this. However, I do have to mention this is a talk on human reproduction. You saw it on the schedule, so you all came voluntarily of your own free will on that. We have to use some words in this talk. They're all taken out of medical literature. I'm going to treat you like you're a medical student and you're reading medical text. So is everybody comfortable with the word egg? Okay, egg, egg. Everybody's all right with egg? Okay, good. We'll go up. What's the counterpart to an egg? It is a sperm. Oh, you guys are Californians. You say that all the time. So I'm sorry, I forgot. You're not like from Alabama where they say, they don't get it out, you know, but, okay, sperm on that. And one of my slides uses the V word, Okay, think about that for a second. Has everybody kind of got the V word in your mind? Now you've pictured it. Look at that. We've broken the ice. Everybody's uninhibited now. All right, all or nothing unity at the cellular level. It's a wonderful drawing of this gargantuan sperm right on the end. This is right from a medical text. Already you see multiple levels of design. Right here in the head, the DNA is tightly, tightly coiled. Dad's contribution to a new human being. At the very tip, you see something called an acrosome. We'll talk about that. A very important design feature. A little powerhouse right here that will whip this tail along so that this single cell is a mobile cell. It can actually move, it swims. You have several cells that can do that in your body, but this one is a real good one. It's fast. Actually one of the tiniest cells in the human body. Very, very, very tiny. In contrast to an egg, and this is a drawing of a freshly ovulated egg, which is the largest cell in the human body. Well, only half of you have them, but it's the largest cell around. And you notice that it's not smooth like a hen's egg. It has all of these cells on the outer side of it. That's called the corona radiata, or the radiating crown of this egg. It actually goes 360 degrees on a sphere like a basketball. But these were cells which were part of the ovary. And when this was ovulated, they detached, and now they stick to this egg right here. And you'll notice how teeny-weeny a sperm is compared to an egg. But both of them have this important contribution, which is DNA for a new person. All right, guys, let's talk about how sperm are made. They just don't show up by magic. You know, we have to build them through a process, and they're built through a process from a cell which continually divides called a stem cell. You've all heard of stem cells. They divide and divide and divide all the time. Now you notice that the stem cell here is round and spherical like a basketball. And all of the organelles, the tiny little components inside the cell, are distributed around. But there's a lot of information. And over about 60 days inside a testicle, all of these organelles will redistribute. These little powerhouses called mitochondria will begin to migrate over here to the midpiece. And then a series of many, many microtubules linked together. Just incredible. They're going to be linked together in multiple layers so that the microtubules can slide past each other under the influence of these mitochondria so that this tail can move and it can swim. And then it's going to undergo a massive weight loss program. It's going to shed all of that extra cytoplasm, and it's going to lose it, and then it's eventually going to be recycled. So that in 60 days, it goes from this spherical, kind of a beached whale of a cell to this real lean, mean swimming machine at the end of that period, so that it can actually swim really in a phenomenally long journey, considering it's microscopic, how far it has to swim, all the way up to an egg. Now they developed behind a very important structure called a blood-testis barrier. You wonder, what in the world's a blood-testis barrier? Well, in your body you have several membrane barriers. One of them protects your brain from a lot of foreign invaders, called the blood-brain barrier, and this one protects developing sperm from the blood system, called the blood-testis barrier. Now why would that happen? That's because, here's a little immunology, when your immune system, and I'll just use this so everybody knows about it instead of referring to an interface today, when your immune system is developing, for all of us, when we're a tiny little embryo inside our mother's womb, your cell has markers on them, lots of cell markers all over your body, and they are unique to you. And your immune system, when you're very, very small, is programmed to recognize these markers, and only your markers, and they recognize them as self. And anything on your body that doesn't have those markers, it recognizes as we saw yesterday, what? Non-self. Non-self. And we think in terms of attack, but it's really a regulatory mechanism where it will try to destroy things that are non-self in order to regulate them. Well, boys don't start producing sperm right from their mother's womb. In fact, they're usually, 12, 13 years old before that starts to happen, before their voice starts to change and they go into what? Puberty. Puberty. That's when the sperm start to be developed. Well, they have markers on them as well, but the immune system has not been programmed to recognize them as self. So the immune system would do what? Destroy them. Whoa, you need something to protect them. And that's what this is. This blood-testis barrier protects them. And here's a drawing of what it looks like from a medical textbook. This is a cell called a nurse cell or a Sertoli cell, and they have these really long arms. The long arms stick out, and you can see they kind of like join their arms together. Here's a stem cell where the sperm are there before it has these markers on it. It slips through the gate, and then it goes through this process of dividing and forming into a mature sperm cell right there. Well, these two cells make that blood-testis barrier. And this is what it looks like in real life. This is a biopsy of real tissue. And normally it's clear, but it's been stained. So the cells are stained pink, and the DNA, or the nucleuses, have been stained. They're really dark blue, but they come across almost black. So you're looking at the chromosomes right here, and this is this blood-testis barrier, and you can see these cells are in the process of maturing into sperm cells. Now this biopsy, they take a hollow needle, and they stick it into the side of a testicle, and they pull out a little bit of tissue so they can sample that. Well, that's probably not the highlight of this guy's day on there, but his pain, our gain, because we get to actually see this process happening right here. You've probably never seen this before, but it's an actual process where they develop and everybody can see, look, these look like regular sperm cells right here, and they're ready to be released. Well, this is what a medical textbook says why this barrier is so important. Not all self-antigens, we'll just call them self-markers, are exposed to immune scrutiny during fetal development. Consequently, they escape being recognized as self. Similarly, developing sperm cells are shielded from the immune system by the blood-testis barrier, and because sperm cells are not formed until puberty, the immune system is not exposed to their antigens or markers. If the testes become inflamed, as if you get a disease like mumps. When I was a boy, my mom used to say, you don't want to get mumps, you'll go sterile. It's like, scare me to death. Why would she say that? Well, because mumps is a viral disease that causes your glands to swell, and a testicle is a gland, and it could swell, and then your immune system could be exposed to that. However, the sperm antigens may escape into circulation. The testes then become a target of the immune system, which causes what? Sterility. Well, sterility from an evolutionary standpoint is a bad thing. It brings evolution to what? A screeching halt. And you don't get a second generation to get it right. That's why the reproductive system is an excellent, excellent illustration with your friends, because you can make up a story about the evolution of an eye, because you say, well, the next generation they did this, and the next generation they did this, and the next generation, and they make up a long story. With reproduction, you don't get a next generation. You have to get it right from the get-go. And whether it's human reproduction or dog reproduction, cat, sea urchin, jellyfish, all of them, it has to be right from the very beginning. And I can guarantee you this, a jellyfish's reproductive system is also very, very complex. It's very, very complex, it's just different, but it's very complex. So we can ask the question, how in the world did sperm cells ever develop before there was a blood testes barrier? How did they develop without nurse cells to make that barrier? That's really important. The absence of either one of these, of course, we know results in sterility, but here's the kicker. The information to make that barrier in those nurse cells is carried on the sperm. So you need those things to make a sperm, but the information to make those other structures is on the sperm. You're caught in a classic what? Chicken and egg scenario, where everything has to show up at the right time. And in fact, the entire discussion of the origin of life is one chicken and egg scenario after another. You have to be able to metabolize energy. That's a chicken and egg scenario. You have to be able to reproduce. This is a chicken and egg scenario. You have to be able to manufacture DNA with proteins. Chicken and egg scenario. It's all over the place, and that's why no one has a clue about a natural origin of life. Nobody can explain it. However, the fact that all of these things are working together in a fully functional system, I would say, is classic evidence of design. Just like my clicker is a fully functional, unified system. That's what reproduction is. Wow. All right, guys. Whew. We're off the hook. No more talking about anything on your body. That's it. From this point on, we switch to the women. All right? Because they really kind of run the show, or they think they do. We're going to find out that baby is actually running the show here. Okay, fertilization. As it says here, the first cell of a genetically distinct human being. I didn't say potential human being, a real human being. Real human being, of which nobody on this planet has ever had the same genetic makeup, materials, and nobody on the planet ever will. Everybody is absolutely, totally, 100% genetically unique. Even identical twins are not exactly the same. Everybody is genetically unique right there. Now, we normally think of fertilization as a really simple process. When I was in high school, my biology teacher told me, all that has to happen is Sammy's sperm needs to meet Elvira egg, and fertilization happens. Isn't that what you kind of taught? Just all happens. And it seems to happen all the time with high schoolers these days. But it's not by any means a simple process biologically. In fact, it's very, very complex. I'm going to make a prediction by the time I get through talking about fertilization, some of you are going to want to say, praise the Lord. And I've done this talk many, many times, and I've been to some churches where I just get to the fertilization, and I've had people stand and applaud. Not me. It's just that this is such an elaborate process. It's so incredible of what actually happens. So, now we're inside a woman. If we were all little surgeons, and we can make an incision down around the pelvic region, and you could pull the skin back and retract it, and look inside, this is what you would see. It wouldn't be gray, it would be pink and it would be glistening, but you'd see one of the main reproductive organs here, the what? The uterus. My teacher was from India who called it the uterus. The uterus, but I Americanize it, it's a uterus here, and you see up here fallopian tube, or it's going to sweep sperm cells in if they're in the presence. It's going to sweep an egg in if they're in the presence. Excuse me, it's going to sweep this egg in if it's in the presence, ovulated. And you see the ovary here held by its ligament. And everything is kind of held in place by this really big, broad ligament. Now, a broad ligament is just a big layer of tissue which goes over everything on the top and the bottom. Kind of like one of those seal-a-meal vacuum things where you put it in and then you kind of go, you suck it out and it kind of holds everything in place. That's what the broad ligament tends to do. It tends to hold everything in place, so these are still a little mobile in surgery on that. Now this is a great picture. It was drawn by a British anatomist whose name was Gray, and he wrote a textbook still in use called Gray's Anatomy on that. Now I can show you this picture here in California because you're somewhat sophisticated, but if I go to Texas I have to use like a chalk drawing or something that they can understand. And this is what is really happening here. If you look inside a uterus, you have an outer muscular layer called the myometrium, which is eventually going to push the little baby out. And then you have an inner layer, the endometrium, which grows and is shed every month. And this becomes just right for a little fertilized egg that's already dividing to implant inside of it. So once a month, usually one egg, sometimes more, are ovulated. They ripen, they mature, boom. They're swept into the fallopian tube or the uterine tube by these fimbriae, and if sperm are present here, fertilization could take place and implantation could take place. But you notice I say if sperm are present. If isn't in the sense of just whether intercourse has happened or not, but whether the sperm can actually make it to that egg. This is what this medical text says. Although sperm are self-propelling, their journey through the female reproductive tract is a difficult one, to say the least. Why is that? Well, first of all, the acidity of the vagina is hostile to the sperm, and millions of them leak from the vagina or die almost immediately after being deposited there. There's some mass casualties of these sperm. Survivors. Now you have to kind of picture this in your mind. It's like landing on Omaha Beach. You know, there's a lot that are dying, and they need to make it to the pillboxes. And if you've ever seen Private Ryan there, or Saving Private Ryan, survivors do what? They forge ahead through the cervical mucus and upward through the uterus and into the uterine tubes. But unfortunately, within the uterus, thousands more sperm are destroyed by resident phagocytic leukocytes. Now, what in the world is a resident phagocytic leukocyte that's doing this? Well, a leukocyte, leuko means what? White. Cyte means cell. So this is a white cell, which we know what those do. They're part of your immune system. And they're phagocytic. If you know a little Greek, phagos means to what? Eat. Eat. So these are cell-eating white cells. And they're resident, meaning they live in the uterus. That's their home. They're uterus-living, cell-eating white cells. That anything that gets in there that's not marked as what? Self will be destroyed. Well, obviously, sperm don't have self-markers on them, do they? So here these things swarm in, and they start killing off some of those sperm. And then look, it's estimated that as few as 1,000 and sometimes fewer than 500 sperm out of the millions in the male ejaculate finally reach the uterine tubes, where the oocyte, that's the egg, may be drifting leisurely toward the uterus. Wow. It's like a little story of life right here. Here comes the egg, and then these sperm, you know, trying to find their way up there on that. That's an amazing thing. But some of them do. Some of them find their way. So, a sperm count of less than 20 million per milliliter, that's a cubic centimeter, makes impregnation improbable. 20 million. That's a large casualty loss right there. 20 million. Well, how many sperm does the average man make in a day? Well, the average guy makes 200 to 300 million sperm per day. 200 to 300 million. Some of us make a bunch more than that, of course, but the average guy makes about that many on there. Well, why do they have such a hard time? Well, obviously, if baby is inside this uterus and baby can get out, then there's the possibility that a bacteria could get in, or a virus could get in, or a fungal could get in. And unlike a man, you could go through the vagina, through the cervix, up through the uterus, out the fallopian tube, and touch her liver. But very, very few women, and I mean very, 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 very few women ever get any kind of pelvic infection like that. That's because there's barriers, protective barriers, all around to help. First, we already mentioned the acidic environment. And it's not just hostile to sperm, it's hostile to other kinds of foreign invaders as well. And then, most of the month, there's this thick mucus plug right here in the cervical opening. You know, mucus is, we don't like mucus that much, and today I don't like it at all. But generally, it's very, very useful. And if you can envision this like a bottle, this is like a cork right in the bottle, just kind of plugging it off, keeping a lot of invaders down. On top of it, the uterus is lined by cells that have tiny microscopic fingers on them called cilia. And they move in an organized fashion, not just randomly or chaotically. They move like if you see people rowing a boat, like a team of people rowing a boat. They say what? Stroke. And all of them stroke at the same time. All the oars go together, and it propels the boat in one direction. Well, all of these cilia move in a rowing-like fashion, and it has a rhythmic contraction which tends to push things out of this uterus. So there's a current that's going in that direction. And then don't forget about those resident phagocytic leukocytes, all those immune cells, microscopic, thousands of them, all crawling around inside the uterus like little hitmen in there. So when you look at this, you're obviously, look at all these defenses, and there's even more. I just put these 4 up to save some time. You're asking yourself, you know, what in the world is a lonely sperm to do? You know, how does it ever find its way to an egg? You notice this? Why do we always, you know, sperm is, we automatically personify it to be what? A man. And the egg, we personify it to be what? Woman. That's the way it is. And it kind of looks like that, but it's not really that way. But the personification works on this. Well, along with the sperm, there are seminal fluids that are deposited, and they neutralize this acid on contact. And not only do they neutralize the acid, they bring it to almost a perfect neutral pH in the middle. And then when the sperm are exposed to that, that's when they start to swim. That's when they really start to move. They need this neutral environment, and it activates them. And then I could, since we have a little bit of time, there are some sugars and other compounds in the seminal fluids which act as nourishment to those sperm so they can actually get the energy and start their trek. Now you can see this is a long way to go, particularly if you're microscopic. That's a long way to go. What about that thick mucus plug? How do you get through that wall? Well, the seminal fluids also have substances which cause that mucus to turn thin and watery. So watery that a sperm can now swim through it. Right through that and make its way forward. What about those flushing rhythmic contractions? Well, this is interesting. The seminal fluids have substances when upon contact with the cervix, they cause that rowing to reverse direction. So instead of rowing to push things out, they reverse and they start rowing to pull things in. And so the sperm, as they're swimming up, they're not swimming against the current. Now they're swimming with the current and moving themselves forward. Now think about that. This is a substance which is made in a man's body, coded for by his DNA. He's making it, and it's having its effect on a woman's body. I wonder how long it took numerous successive slight modifications to get that right. You know, it takes a long time for those kinds of things to happen. You think about that. That's quite phenomenal right there. And this is what it looks like. I don't know how they got this picture, and I won't even ask. But this is a micrograph. This is the uterine lining. You notice when it's highly, highly magnified, it's not smooth. It's rough. And those are those fimbria, and they've changed direction so that this sperm, greatly magnified here, can swim forward. And what's even interesting, I'll point this out, look at this texture. You know what those are? Those are muscles. Muscles underlying the mucosal layer of the uterus, and they're rippling inside that uterus there with just this layer over it. And not only do the cilia move in a rhythmic contraction, the muscles move like waves. And the muscle contractions change direction at the same time. It's all quite amazing. And then look at this. I'll just point this out right here. That's a cell. That's one of mom's cells. Guess what that one's called? That's a resonant phagocytic leukocyte. Right there. You can see it. This is a white cell, and they're also mobile. And this is like a bomber, and this is like a fighter. And it's zipping its way, and it will want to destroy this cell. So how do you handle all these immune cells? Well, in seminal fluids, there are also substances which cause local suppression of mom's immune system. Not throughout her entire body, but just within the uterus, and not a complete suppression, just enough. Suppresses her immune system just enough, dulls it, makes it a little sleepy, so to speak, so that some of the sperm cells can actually evade those white cells and make it over to an egg. Now that's interesting. Well, you think, well, you've just blunted her immune system. Maybe that's a great time for a bacteria to make its way in too. Well, it might, except the seminal fluids also have another substance in them which has antibacterial properties. So not only does it suppress her immune system, it provides antibacterial support at the same time, so it's doing it. Now you're wondering, how long did it take what? Numerous, successive, slight modifications to get all of these things working so that this sperm could find its way to an egg. But is there anything in a mom's body which codes for her DNA which has an effect on the sperm? And the answer is yes. If you look here at the tip of this sperm, there was this structure called an acrosome. An acrosome is simply a sac of enzymes. Enzymes that are able to dissolve tissue. Dissolve tissue. If you recall, when the egg was ovulated, there were cells all around it. Remember that? The corona radiata. In order for these sperm to get to the membrane of that egg, these enzymes must be released to dissolve their way through those tissues. And you have to release hundreds of them. Well, they can't be released on their own. As they swim through the uterus, there are chemicals and compounds in the uterus which actually capacitate the sperm, changing the outer membrane of this acrosome so that it can actually release its enzymes right on cue. And so here's a substance made in mom's body which is having its effect on these sperm. And this is a new drawing I've added. It came from New Zealand. They have kind of an interesting sense of humor there. It shows how these sperm go through these different environments and they're actually changed. It's called cervical scrubbing. This is a scientific term. So in the vagina you have 3 different sperm. You've got the happy sperm. There's no defects with this sperm. You've got the sad sperm. It's broken in some way. And you've got this one that doesn't know whether it's happy or sad yet, but we'll find out. The thing is, as they swim through the environment, not only are those markers changed, but there are elaborate processes in the uterus which are checking these sperm to see if there's any defects. This one checks out okay. This one doesn't. It has reactive oxygen species. That's a substance like hydrogen peroxide, which schwacks it. Bang, it's gone. This one right over here, it's not going to make the grade either, and it's eventually going to get wiped out. But this happy sperm makes its way all the way in through the uterus, and not only does it not get marked off, special markers, as you can see, are being placed on it so that it approaches the egg. It can actually release its enzymes and affect fertilization of that egg. Wow, this elaborate testing process as sperm swim through the female reproductive tract. Who would have ever guessed such complicated features in design? right there. This is called rigorous quality control. Yes, ma'am.
I've heard that in the case of a rape, that things don't always happen this way.
I don't know why not.
Probably the emotional state or other
Maybe.
physiological things that happen.
Yeah, I don't know. I doubt that would probably change on those things.
I just heard it and I was wondering if it was true.
I've never heard that, and it may be true, but right now I'm skeptical that it would be true. This process is probably going to seem to function regardless. That's it. So, this is what the medical text says. As sperm, why do we have this process? That's a good question. Why? As sperm swim through the cervical mucus, uterus, and uterine tubes, they, that is the sperm, undergo a gradual capacitation for the next few hours. There's a pretty elaborate mechanism for preventing the spilling of those acrosomal enzymes. Remember, they can dissolve tissue. But consider the alternative. If sperm had fragile acrosomal membranes while still within the male reproductive tract, they could rupture prematurely, causing some degree of self-digestion of the male reproductive system. Wow, guys, that could ruin your day. I mean, that is a terrible thought. I mean, it's just like incomprehensible here. I wonder how long it took numerous, successive, slight modifications, and how many guys were maimed for life until they got this right. Well, this is an amazing thing. Amazing thing. So, now, finally, the story continues. Sperm have made it to the egg. And this is what we see. We see a portion of the egg drawn very, very large. We see time. This is going through time from left to right. Here comes a sperm getting close to this egg. Here's its acrosome. It releases the enzymes, dissolving its way through the outer part. Now, what makes it release its acrosomes on cue? Well, there are these tiny little receptors. They're really actually sperm detectors on the outside of the egg. And they can detect when a sperm is in presence. They send out a signal the sperm recognizes, bang, releases the enzymes. As it gets close, tiny little microtubules grow from within inside the sperm, and they will attach to that detector. Just like a key in a lock, boom, and attaches to it. And then they will begin to fuse with the membrane of the egg. And here we can see the cell membrane of the sperm has fused with the membrane of the egg. It doesn't show you in this drawing, but the egg also sends little microtubules out. The microtubules capture the DNA. They surround it. They pull it inside of the egg. The chromosomes will align up and bang, fertilization has now finally taken place. This is an amazing mechanism right there. As you probably say, it's a miracle. It's like a miracle that this ever happens. And now you have the first cell of a new human being, which is going to develop into trillions of different cells. Well, we do want a sperm to fertilize an egg, but we want only one sperm to fertilize an egg. Well, how do you prevent more than one sperm from fertilizing an egg? Well, there's three methods. There's a fast method, where once this receptor, this detector, is contacted by the sperm, like I say, a lock and a key, an electrical charge will be released by the egg. And bang, right on cue. And any sperm still in contact are shocked away, zapped. They get a little shock and they kind of like, ouch, and they're repelled away from that. And then little granules are released from inside the cell membrane, and they absorb water. And water then flows by osmosis through the membrane and makes the membrane of the egg so thick that another sperm cannot get through. And this is another one I just found out a couple of years ago. Once these receptors, you notice how many there are? Thousands of them, and thousands all over the egg. Once a sperm touches one of those, just one of those, all of the others, all the other thousands, immediately change their shape so another sperm cannot lock onto it. And these all happen within milliseconds. Very, very fast. Sometimes they break down, like everything, and two sperm will fertilize an egg. But it doesn't grow into a human being. It grows into, more likely, a cancer, because it has deranged DNA, just like a cancer will. So you must have these mechanisms in place. Therefore, it makes it highly implausible that numerous, successive, slight modifications ever brought this into existence. If you want to hear about this, you guys are already creation savvy and you've probably signed up for Acts and Facts. But if there are any renegades out here who haven't signed up yet, please sign up for this free magazine. It will explain it to you. This book is out there which explains all of this to you. And this one will tell you how to explain design to your friends. Most of you probably already have these books. And there's a DVD of this talk out there and a new Made in His Image DVD. All right, we have 5 minutes to go from here to baby. We can do it. Egg is fertilized, makes its way through the fallopian tube, starts to divide, 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 divide. By the time it makes its way to the uterus, it's already a completely changed state. It will implant inside the uterus. Look at this little picture right here. These are enzymes that are being released by this egg, which are dissolving their way into the endometrium so it can affect implantation inside of this uterus. Now this is the picture that we normally have in our mind. This is what we're taught in school. Baby is this passenger. This is an ultrasound of a tiny little baby boy. Can everybody see his little foot here? His shin bone, his femur, the buns, right there, all of that inside of mom. The old understanding is that baby was a passenger. And this is what a OBGYN textbook, OBGYN, guys, that's obstetrician, gynecologist, right there. This is what it says about this. In the past, the fetus was envisioned as a passive passenger of the pregnancy unit. Baby's like along for the ride, and mom's going to make a baby on that. Of the pregnancy unit. What's a pregnancy unit? Mother and child. One pregnancy unit equals one mom, one baby, one pregnancy unit. The text goes on to say, but nothing could be further from the truth. It, that is the fetus, is the dynamic force in the orchestration of its own destiny. Well, this makes sense. As I mentioned yesterday, living organisms self-develop, self-maintain, self-repair, self-adjust. If biologists could just get this into mind. So here we have a picture of an obvious pregnancy unit on the screen, right there. What in the world is happening? Well, inside of her, her own immune system needs to be suppressed by that implanted little embryo, and it needs to stay suppressed throughout the entire pregnancy. Why? Because her body would now recognize a cell with dad's DNA in it as what? Non-self. Can she destroy a single cell or a single ball of cells? Of course, very easily. But from the moment, actually, of fertilization, signals are being sent to her body to suppress her own immune system and throughout the pregnancy so that pregnancy can be maintained. And baby and the placenta are sending out these signals into mom. Hormones now need to circulate around her body, primarily estrogen and progestationerone, that will keep this pregnancy going for 9 months. Guess where these hormones are predominantly being made? Inside of baby and the placenta. They are pumping these hormones into mom's body, saying, you will maintain this pregnancy for me as I begin to develop. Mom's body needs to recognize that it is pregnant weeks before she even knows she's pregnant. Before she says, hey, something's missing here. I might be pregnant. Her body already knows that it's pregnant. There are at least 24 signals which go to mom's body saying you're pregnant, and the fertilized egg and then the placenta throughout the entire pregnancy are sending these signals to mom's body saying you're pregnant, you need to change now so that I can begin to function. And those are all coming from baby. On top of that, mom needs to increase her blood supply because not only does she need it for herself, but she needs to have extra blood to circulate around that placenta, and she's going to lose some on delivery. Well, her blood supply is going to increase because baby is going to send signals to mom's body, which she will respond to by increasing her blood supply. But of course, if you pump up a lot of additional fluid into the pipes, the pressure could go way, way up. But at the same time, baby sends signals to mom's body controlling her blood pressure for her. In addition to this, mom's metabolism needs to crank way up because she has to metabolize for herself, placenta, and have nourishment for the baby. Well, we all have heard about thyroid hormone, how it controls metabolism. Baby is going to dump another hormone into mom's body, which is very similar to thyroid hormone, which is going to crank mom's metabolism sky high. So that in the non-pregnant state, most women are like kicking the covers off, are putting covers on them at night, but when they're pregnant, they're hyperdynamic and they kick them off, they're hot, all of those things. Don't get close to me. You hear all that stuff, I'm hot, because she's in this hypermetabolic state, and baby is turning her into that. As you can see, this uterus is getting much larger. She's just a few weeks away from delivery, and it needs to be primed for delivery. How do you prime a uterus? Well, you increase receptors all over it for a hormone called oxytocin. Oxytocin, man-made oxytocin, is called what? Pitocin. Well, the receptors increase on the outside of this uterus because mom's estrogen level starts to rise dramatically. Now, where does the estrogen come from? Well, mom has components for estrogen. They cross the placenta, go into baby. Baby, whether it's a male or a female, makes lots and lots of estrogen, pumps it out, crosses back over the placenta into mom's body. Her estrogen level rises. As it rises, those receptors increase in number on the outside of that uterus. And the closer and closer and closer she gets to her pregnancy, the more the receptors are, and her uterus becomes somewhat irritable. She starts getting false contractions called what? Braxton Hicks contractions as she gets closer. On top of that, mom's going to push something out of her body about the size of a watermelon. That normally doesn't happen. And so all of that skin needs to stretch what? Enormously. And those ligaments need to stretch. Pelvic ligaments need to stretch. Well, a hormone will begin circulating in her body as pregnancy goes on called relaxin. And relaxin relaxes the collagen in skin and ligaments so that they can stretch and they can flex at just the right time. And guess who's making the relaxin? Baby's making the relaxin and putting it into mom's body. And guess who's happy baby is? Mom is on that. But baby's also happy because baby doesn't want to get stuck on the way out. So this works for everybody there. And then on top of that, baby wants something to eat once baby's born. So throughout the entire pregnancy, a hormone called prolactin is going to be produced. It's going to circulate around mom's body. As the medical textbooks say, her breasts will reach optimum physiological and morphological maturation. You know, what in the world is that? That means they get bigger. And so when baby is born, baby is going to get something to eat, and guess who's making the prolactin? Baby is. So who's really running the show on all of this? Baby is. See, these are but a few examples to indicate unambiguously that the embryo, fetus, that's the baby and the placenta, or both, direct the orchestration of the physiological adaptations of pregnancy. The maternal organism, otherwise known as mom, passively responds even at times to her own detriment. What that's saying is, if baby wants something, if baby needs calcium, baby gets it. If baby wants iron, baby gets it. And mom goes without during that pregnancy. That's what it means. And that continues for the rest of mom's life. Anyway, so it's like, there you go. Clearly, the baby acts to ensure its own survival. So what do you need to get a baby? You need dad to get a baby. You need mom to get a baby. And you need a baby to get a baby. You don't get that by numerous, successive, slight modifications. It takes a baby to make a baby. And I would say Darwin's theory has not just been broken down, it's been crushed. Amen? Amen. Now, how many of you feel like saying, praise the Lord? Amen. Thank you.